Welcome to today's video, where we explore one of the most fascinating rivalries in scientific history, Albert Einstein versus David Hilbert. When we think of general relativity, we instantly associate it with Einstein. But what if I told you that David Hilbert, a brilliant German mathematician, was working on the same equations at the exact same time? In fact, some people argue that Hilbert may have derived the Einstein field equations first. This has sparked a long-standing debate. Who truly deserves credit for general relativity, Einstein or Hilbert? In this video, we will break down the historical timeline, the scientific contributions of both men, and attempt to determine who should be remembered for this monumental achievement in physics. Before diving into the contributions of Einstein and Hilbert, it's important to understand why the world needed a new theory of gravity in the first place. For centuries, Newton's law of universal gravitation was the gold standard for explaining the attraction between objects in the universe. Newton's equations worked well for most practical purposes and accurately described the motion of planets, the falling of objects on Earth, and the behavior of celestial bodies in a predictable way. However, as precise measurements and deeper investigations took place, two significant flaws emerged in Newton's theory that could not be reconciled. The first issue was the unexplained anomaly in Mercury's orbit. Mercury's perihelion, or the closest point in its orbit to the Sun, shifts in a way that Newton's law could not account for. This discrepancy, known as the perihelion precession, was too large to be explained by known perturbations from other planets. While scientists of the time speculated that an unknown planet, Vulcan, might be influencing Mercury's orbit, no such planet was ever discovered. This failure pointed to the fact that Newton's theory was incomplete in explaining certain celestial phenomena, especially those involving strong gravitational fields near massive objects like the Sun. The second critical flaw was that Newton's theory conflicted with the principles of special relativity, which Einstein had developed in 1905. Newton's formulation treated gravity as an instantaneous force that acted across space, meaning that if the Sun were to suddenly vanish, Earth would immediately cease to feel its gravitational pull. But this instantaneous action at a distance violated the principle of special relativity, which held that no signal, including gravity, could travel faster than light. This raised serious doubts about the validity of Newton's law in the context of the relatively new framework of special relativity. The incompatibility between the two theories became especially apparent when dealing with high speeds or strong gravitational fields. These inconsistencies highlighted the need for a completely new theory of gravity, one that could explain Mercury's orbit, respect the speed limit of light, and integrate seamlessly with the relativistic laws of physics. By the early 1910s, Einstein was already working on a new theory of gravity. He began to suspect that gravity was not simply a force acting at a distance, as Newton had described, but was instead the result of the curvature of space-time caused by the presence of mass and energy. In Einstein's view, massive objects like stars and planets cause a warping of the fabric of space-time, and this curvature dictates how other objects move through space and time. To mathematically describe this, Einstein needed a set of equations that could explain the relationship between mass, energy, and the curvature of space-time. However, formulating such equations was no easy task. Einstein struggled with the complex mathematics involved and the difficulty of describing gravity in this novel framework. At the same time, David Hilbert, one of the most prominent mathematicians of the time, also became deeply interested in Einstein's ideas. Hilbert had extensive experience in the field of mathematical physics, and he had access to some of the brightest minds in science. In 1915, he decided to take a more mathematical approach to the problem of gravity and began developing his own set of equations for general relativity. This set the stage for what would become a famous scientific race between Einstein and Hilbert to derive the correct mathematical formulation of gravity in the context of general relativity. The most intense period of this scientific race occurred during November 1915, as both Einstein and Hilbert worked diligently to complete their theories. On November 4, 1915, Einstein presented an early version of his field equations to the Prussian Academy of Sciences. However, this initial version was still incomplete, and Einstein himself recognized that it contained several errors and inconsistencies. Despite these flaws, he was making significant progress and was getting closer to the final solution. He was aware that his equations were not yet fully developed, particularly regarding the way mass and energy were connected to the curvature of space-time. By November 11, 1915, Einstein had refined his equations further. He realized that his earlier approach to the equations had some fundamental flaws, especially with how mass, energy, and space-time curvature were related. He corrected his approach, but still faced challenges in obtaining the precise final form of the equations. The road was difficult and required overcoming mathematical obstacles that had never been encountered before in physics. On November 18, 1915, Einstein made a major breakthrough. He successfully applied his equations to explain the anomaly in Mercury's orbit, specifically the shifting of Mercury's perihelion, which had been an unsolved mystery in physics for decades. This was the first strong confirmation that his new theory could make accurate predictions about planetary motion that Newtonian physics had failed to account for. This achievement brought Einstein a step closer to finalizing his theory and bolstered his confidence in the validity of his work. Meanwhile, on November 20, 1915, Hilbert submitted his own paper to the Göttingen Academy of Sciences. His equations were quite similar to Einstein's, which led some to believe that Hilbert might have arrived at the correct form of the equations first. However, upon reviewing Hilbert's original submission, historians found that the equations in his paper were not the exact final form of the Einstein field equations. In fact, it appeared that Hilbert had refined his equations after Einstein had already presented his final version. On November 25, 1915, Einstein presented the final and correct version of the Einstein field equations to the Prussian Academy of Sciences. This version was free of the errors from his previous drafts and was mathematically consistent. This is the form of the equations that would go on to form the foundation of general relativity. While Hilbert had submitted his paper earlier, there is no strong evidence to suggest that he arrived at the correct final form of the equations before Einstein. Over the years, some critics have suggested that Einstein may have copied Hilbert's work or been influenced by his equations. However, there is no strong evidence to support this claim. When Einstein finally presented his equations on November 25, 1915, he did not cite Hilbert in his paper. This suggests that Einstein was working independently, despite the similarities between their approaches. Additionally, Einstein had been refining these equations for years prior to November 1915, and his approach was grounded in his physical intuition and understanding of how gravity interacts with space-time, rather than purely on mathematical formalism. Hilbert, for his part, never accused Einstein of stealing his work. In fact, in later years, he admitted that Einstein deserved full credit for the discovery of general relativity, acknowledging the significance of Einstein's physical insight into the nature of gravity. As Hilbert himself put it, "Every boy in the streets of Göttingen understands more about four-dimensional geometry than Einstein, yet it was Einstein who discovered general relativity." After decades of historical research and analysis, most physicists and historians agree that Einstein is the true discoverer of general relativity. Einstein presented the final and correct field equations on November 25, 1915, whereas Hilbert's paper, though important, did not contain the complete and correct equations at the time of submission. Einstein was also the first to successfully test the equations through his explanation of Mercury's orbit, a significant result that helped validate his theory. In contrast to Hilbert, who approached the equations primarily from a mathematical perspective, Einstein's contribution was rooted in physical reasoning. While Hilbert was undoubtedly a brilliant mathematician, it was Einstein's deep physical insights into the nature of gravity and space-time that led to the development of general relativity. Even Hilbert himself acknowledged that Einstein should be credited with the discovery of general relativity. While Hilbert made significant contributions to mathematics, general relativity remains Einstein's vision, a revolutionary way of understanding gravity, space-time, and the universe itself. The Einstein versus Hilbert debate is about more than just who wrote the equations first. It's about how scientific progress is made. Einstein's ability to connect mathematical concepts with real-world physics is what ultimately made him one of the most influential scientists of all time. If you enjoyed this video and want to learn more about the fascinating world of science and history, be sure to like this video, subscribe to our channel, and leave a comment below, sharing your thoughts on this incredible rivalry. Did you find Einstein's physical intuition more impressive or Hilbert's mathematical rigor? Let us know. Thanks for watching, and as always, stay curious.